Let's hop on to Lesson 2, the complexity of sustainability. In the previous lesson, we discussed the triple bottom line and how sustainability sits at the intersection of environmental, social, and economic performance. Operating at that intersection is not simple. Sustainability becomes complex precisely because it requires balancing multiple priorities at the same time. Each dimension affects the others. So in this lesson, we're going to explore why sustainability is inherently complex. And as we do that, we'll begin connecting this complexity to an important concept, systems thinking. Let's recap so far. We've explored how sustainability lives at the intersection of people, planet, and profit. But here's the thing. These aren't just categories to balance. They're deeply interconnected systems that evolve, react, and adapt. That's why it's not enough to look at issues in isolation. We need to step back and learn how to see the bigger picture. We need to think in systems. Systems thinking is an approach that helps us understand how different elements, people, processes, environments, technologies, values, interact within a larger whole. Systems thinking is about understanding the world as a web of interconnected parts, where cause and effect aren't always linear, and short-term fixes can create long-term problems. In simple terms, it's about seeing the forest, not just the trees. When we use systems thinking, we stop asking, what's the problem? And we start asking, what's connected here? What patterns keep repeating? Where are the feedback loops? What's the system trying to achieve? Sustainability challenges are not isolated. Climate change, for instance, isn't just about carbon, it's about governance, culture, economics, energy, technology, and more. These aren't problems with one cause or one fix. They're complex systems, challenges that require an entirely different approach. As economist Jeffrey Sachs put it, there is no one force, one formula, one answer. We need to embrace complexity because we are dealing with interconnected systems that span the globe, linking people, technologies, economies, and the Earth itself. This recognition sets the foundation for systems thinking. In systems thinking, we distinguish between simple problems, clear, solvable, often with a specialist involved, wicked problems, open-ended, interconnected, and multidimensional. A wicked problem refers to complex issues difficult to solve due to their intricate characteristics. This concept emerged in the 1970s, critiquing the limitations of rational technical approaches to social planning and public policy problems, notably discussed by Riddle and Weber in their seminal work, Dilemmas in a General Theory of Planning. Wicked problems have no single cause, can't be solved with linear solutions. Span across sectors and disciplines, are open-ended and context-dependent, often lack consensus even about the nature of the problem. Our usual approach to problem solving is reductionist. We take a complex system, break it into parts, and try to fix one part at a time. Example, we reduce climate change to carbon emissions and focus only on CO2, ignoring broader systemic drivers like land use, consumption, or infrastructure. This narrow lens leads to missed interconnections, oversimplified solutions, temporary fixes problems recurring in new forms. We've seen this across many sustainability domains. We chase symptoms while the system continues producing dysfunction. So what does systems thinking offer? Systems thinking invites us to see the whole system, not just the parts. It helps us understand how. Problems emerge from the structure of the system, feedback loops and delays drive behavior. Fixing one issue may impact another. Seemingly unrelated elements are interconnected. We shift from what's the fix to what's causing the system to behave this way. That's the essence of systems thinking. Let's recap. A system is a collection of interconnected elements that work together to produce a particular result or outcome. These elements can be physical, like parts of a machine, biological, like ecosystems, and systems don't exist in isolation. They exist within other systems. They're dynamic, layered, and often full of surprises. To change a system, you must first understand it. That's where systems thinking begins. In other words, everything is connected. Nothing operates in isolation. In sustainability, that might look like a decision about packaging that impacts waste supplier livelihoods and compliance risks. A climate policy that affects food prices, migration patterns, and public health. A supply chain decision that touches labor rights, carbon emissions, most of us are trained to think linearly, A to B to C to D to final result. This kind of thinking assumes that one action causes one outcome, like a straight line. It works great for simple short-term problems, but sustainability challenges, they rarely follow straight lines. In reality, systems are circular, not linear. What we think is an output might actually loop back as a new input. That's called a feedback loop. One of the tools we use in systems thinking is the iceberg model. To solve the problem, we have to look below the surface and address the deeper systemic causes. Let's try, enter mapping a system. Let's walk through an example using a causal loop diagram, a tool we use to map feedback loops in a system. Example. Fast fashion start with a company that notices customer demand for cheap clothing. To meet that demand, they lower costs by outsourcing labor and using synthetic, low-quality materials. Cheap clothes equals more production equals more marketing and new styles. That fuels more purchases. Customers wear, toss, and repurchase, and the cycle continues. Every arrow in that loop reinforces the next. This is called a reinforcing loop, and in this case, it leads to increased clothing waste and pressure on natural resources. Now ask, where can we intervene? Can we change consumer behavior, shift brand incentives, improve regulation? That's systems thinking in action. The takeaway is that sustainability isn't a job title. It's a way of thinking, seeing, and acting through systems logic. So from here forward in the course, we won't just be learning what sustainability is. We'll be practicing how to think sustainably across roles, industries, and impact areas. But here's where it gets exciting. Your power lies in seeing where your experience fits into these systems and using that perspective to create meaningful change. If you're a process engineer, supply chain analyst, or even someone in operations or marketing, you already understand systems, you've already worked with structures, feedback loops, optimization, and complexity. What we're doing now is reorienting that lens toward impact. And if you're in finance, you're not just crunching numbers, like you're shaping the flow of capital. You decide what gets funded, like your understanding of financial systems can literally shift the future. If you're in the supply chain, you're not just moving products, you're managing the veins of the global economy. You touch emissions, labor practices, packaging, sourcing, and materials every single day. You see the bottlenecks, the risks, or the waste. Also see the opportunity, circularity, traceability, ethical sourcing, supplier engagement. That's where real decarbonization and impact happen, and you are already in that rooms. You have a superpower. If you're in engineering, design, or operations, you're wired to optimize, streamline, and build with precision. What if those same skills were used to redesign entire systems for resilience, from green infrastructure to low carbon products, from sustainable logistics to energy efficiency? The tools you already have are the exact ones we need. You just need to reframe how you see what you already know. Sustainability doesn't ask you to leave your skills behind, it asks you to bring them forward into systems that desperately need them. And that's where the transformation begins. Whatever your background, there is a system in your domain waiting to be made better. And more often than not, it needs someone like you, someone who can see the connections and ask the bigger questions.